Hello, welcome back. Here's our next problem we're going to be solving by first principles here. Notice that it's really the exact same configuration. You have a source tied to the non-inverting terminal, you have a source going into the inverting terminal through a resistor, and then you have a feedback resistor that's also connected to the output. The only real difference between this one and the last one, because the resistances here are the same, even the reference direction of the currents are the same, the only difference is that this is 2 volts and this is 1 volt. So where this was grounded essentially before, it's 2 volts now. So we're going to solve exactly the same thing. We want to figure out what this output voltage is and see if it's in the linear region. All right. Now, we can kind of game plan it right now and just see what we would actually do. Well, since we know this is 2 volts, that this non-inverting terminal is 2 volts, then we immediately know that this is also 2 volts. We will then know both sides of this resistor's voltages, so we can calculate this current, and we'll be able to write our Kirchhoff current law, which then tells us what this current is, and then we'll be able to do a voltage loop all the way around because we'll be coming back to 0 volts again. So that's kind of flying through it pretty fast because we've already done one really similar, but you'll find out that we're just going to walk through it one step at a time. And by the way, there's always more than one way to solve a problem. I'm doing it different, the way that I'm doing it here, because I think it makes sense to introduce things. But you can also do other things. You can write a node voltage equation here, and we'll do some problems like that later. You can do some other things, but I like in the beginning here to find one thing at a time to make our way over there to learning what the output voltage is. So let's go ahead and do it right now. All right, so the first thing, as we already mentioned, is we know what the source voltage is. We know that it's connected directly to there, so we know this is 2 volts. So what we're going to write down for our very first step is that V sub 2 is equal to 2 volts. Because remember, the non-inverting terminal, we always call it V sub 2. Because of that, we know that the inverting terminal, V sub 1, is also equal to 2 volts. And if you want to remind yourself of that, you can do that by just writing 2 volts there. You don't have to, it's just something I do sometimes to help me out. Now again, there's many ways that you can proceed. What I'm going to do is find what this current is, I sub 25. Now I've drawn it in this direction, so I'm kind of assuming, since I've drawn it here, that this voltage is higher than this one, even though I can see from the numbers that that's not the case. But you have to respect the direction of the current you've drawn in the paper. If the current were flowing this way, then this really would be higher than this. So the way that you kind of handle that mathematically is you say I sub 25 is equal to whatever voltage is on the left minus whatever voltage is on the right, which would be 1 minus 2. That's the voltage drop across that resistor, divided by the resistance, 25 times 10 to the 3. Now again, I know that this is not bigger than this, but because the drawing is that way, you write it this way, and what you're going to end up finding is that this current is actually going to be negative.